Hello everyone, welcome to PostgreSQL Crash Course Day 18. This is your host Mohan and my WhatsApp number is displayed on the screen. If you want to get connected me with over WhatsApp, you can contact me over there. And if you want to get added into the WhatsApp group, you're most welcome. So in the last video, we have learned about the vacuuming process, how we can do it. In today's video, we are going to learn about more about vacuuming and other maintenance operation. So without any further delay, let's move to the slides. So there are two variants of vacuuming. One is a simple or standard vacuum, and other one is the full vacuum. So this simple vacuum or standard vacuum is a basic operation to reclaim the storage and update statistics, right? So update statistics will only be run when you run a vacuum with analyze command. So if you run this vacuum table name command, so it will basically vacuum the table and it will reclaim the storage. So consider the example of SQL Server log file. Whenever we are doing a log backup, so in case of log backup, all the VLFs or virtual log files where we have the committed transactions, those VLFs will be marked as for reuse, right? Similarly, in case of vacuum also, when you run vacuum standard or without any, like without full, it will simply mark the space of that particular block as like ready for reuse. But it will not release the space to OS. And in case of vacuum full, it will basically it is a more intensive operation that rewrites the entire table, reclaiming more space but requiring more resources and locking the table. So see, there are two things if we compare it with SQL. So for example, how we do the reindexing, right? So on similar way, this vacuum full work, as in the reindexing we need to recreate all those indexes. So here in case of vacuum full, we just rebuild all those tables, and at the end we will just get the space, free space, and that free space will be given to the OS. For example, in our SQL server, when we shrink the log file, then the space will be released to OS, right? So the command of this vacuum full will be vacuum full and table name. So these are the two variants of vacuuming in PostgreSQL. And there are difference in vacuum and vacuum full. First is basic reclaim operation, which releases space for reuse. It's not releasing the space for OS. Other one is extensive rewrite operation, which releases space back to the operating system. And this vacuum process, so it is not acquiring any log because it is simply making those space for reuse. It is not locking the table, but in case of vacuum full, as it rewrites all table, it will exclusively lock the table, does not compact table, and this vacuum full will definitely compact the table and it will reclaim more space. Vacuum is faster and it does the basic operation, but vacuum full will take the longer time because it has to rewrite all the table. Now we have one another concept called vacuum freeze. So vacuum freeze is a special kind of vacuum which marks rows as frozen. So consider our database where where the database size is huge and it has the data for many years. For example, last 10 years data it has, and out of that 10 years of data, we are only working with 1 year of data because all the old 9 year of data, it is kind of archive data. We are not touching it, we are not modifying it, we are not updating it, right? So that so in normal cases, when you run the vacuum, it will scan the whole databases and it will scan the whole tables, all the pages, all the rows will be scanned. But that is not required, right? Because we are not making any changes in all other tables other than the current year tables. So in such cases, we can just freeze those tables, we can freeze those rows which are old and which are marked for archive and where we are not doing any operation. If you do this, it will save a lot of resources and a lot of time, because every time this vacuum will not scan the whole table. So let me read out this, whatever I have just explained. So vacuum freeze marks a table's content with a very special transaction timestamp that tells PostgreSQL that it does not need to be vacuumed over, right? Because we are not making any changes. Vacuum freeze reduces auto vacuum overhead since frozen rows don't need to future cleanup. PostgreSQL spends less time running auto vacuum, freeing up resources for other tasks. Just consider example where we have 100 million of rows and only like 10 million of rows are getting updated. Those 90 millions are doing nothing. It is just for like it is just archive data. We are not making any changes. So if the vacuum will run, auto vacuum will run, it will scan all those 100 million of rows. It will take a lot of time. Instead, if we froze those, if we freeze those 90 million tables or 90 million rows, then it will not scan that. So vacuuming will be faster, and we will be using very less resources as compared to the whole 100 million rows. So queries run faster because PostgreSQL does not have to check transaction IDs for frozen rows, reducing unnecessary computations. Think of it like preserving old documents. Once archived, they don't need further updates, making retrieval faster and safer. So that's what I have explained just now. After that, we will see about the updating planner statistics. So what is this? So what is, as a DBA we know that what is statistics. So basically statistics tell us about the distribution of data, how the data is distributed inside the data files, or how those rows are, like how those pages are arranged. So those all information we just get from the statistics. So PostgreSQL Query Planner relies on statistical information about the contents of table in order to generate good plan for queries. These stats are gathered by analyze command, which keeps the stats up to date about the current state of table. In our last video, we have learned about the analyze command. When we ran that auto vacuum with analyze, we have seen that how that query optimizer will see the information, how it will see the statistics as per the number of tuples, right? So analyze command collects information about size, row count, average row size, and row sampling information. Inaccurate or stale stats can mislead optimizer to choose plans which might degrade database performance. So in our example, we have seen that when we have deleted few of the rows, but still it was showing because we have disabled the auto vacuuming. So those stale table stale entries or stale rows were still showing in our row count. So in such cases, those are the inaccurate state, or we can say like those are the stale stats, and this will definitely give the wrong information to the optimizer, and query optimizer will create the incorrect plan. And in case if we have large table, and if we have more number of those dead tuples, or the tables are bloated, then in that case we will not be able to get the correct statistics for the tables, or for that particular database. Tables with heavy update delete need to be analyzed on a regular basis to ensure optimal performance is achieved. So in case of operations or tables where we are running heavy updates, or like very frequent update and delete statements, then in that case we need to we need to analyze those tables very frequently so that we'll have the optimal performance. We can run analyze command automatically by enabling auto vacuum daemon, or can run the analyze command manually. So we have both the options. Next is routine reindexing. As we know, what is reindexing? Reindexing basically just rebuilding the index. You can say we will create the index again, and all the information will be as per the new data. So insert updates and deletes operations fragments the index over a period of time. A fragmented index will have pages where logical order based on the key value differs from the physical ordering inside the data file. So we already know as a DBA that what is fragmentation. So when the logical order of indexes or the pages are not matching with the physical order. So what are those logical order on what is the logical order and what is the physical order. So we know that indexes are arranged in a B tree manner, right? So we expect that whatever logical IDs or pages ID is there, we expect that all the data or all the pages which are relevant will be present adjacently, right? But for example, if we have a row like 1, 2, 3, 4, 5, and we just generate like the SQL server or the PostgreSQL generates a B tree, and it will keep those pages in order like 1, 2, 3, 4, and 5. But whenever there is any insert or when there is any update is happening, those order are changing, those pages are changing. So when there are more insert, more update, and more delete operations are happening, those order are changing. So after some time, the pages will be not in the correct order as compared to the initial stage of the table. So that is called the fragmentation. Heavily fragmented indexes can degrade query performance because additional IO is required to locate the data to which the index point. In case of like non-fragmented table, everything is arranged in order, so it will take less time and less IO input output. So we will have less IO to locate the pages which we are looking for. But in case of heavy fragmentation, definitely it's gonna take a lot of time because it has to search for all the pages until it finds the required one. Reindexing, rebuild an index using the data stored in index table and eliminates empty spaces between pages. So this is the index command or the syntax of this reindex index, and we can give the index name. Okay. The next is log file maintenance. PostgreSQL logs are records of the database server's activity, errors, and the system messages. So in SQL Server we have error logs, right? So similarly we have these log files in PostgreSQL. So whatever we are doing, it will all be recorded in the PostgreSQL, and even if you are not able to log in into your Postgre cluster, or if you are running any incorrect command which is giving error, all those errors will be record in the log files. So let me show you where we have the log files of like error log files in PostgreSQL. So it will be in the data directory. If you go and if you check here, you can see like all those are the log files. This is not the like transaction log or something, it is error log files, right? So if you open this, it will give information. If there is any error, it will definitely show here, but as of now there is no error. Let me see if I can open any file where we have the error. So as of now, I can't see anything, but whenever we are having any issue with the PostgreSQL, you can go and check all those logs here. So this is all about the information about the log file. So over the time, these files will grow, right? You can see like a lot of files are there. This is a test system, and every time when I restart SQL, you can see like PostgreSQL, you can see those files are getting created. So in case of prod system, these files can be larger. It depends on the errors which you are receiving and how many times you are restarting your PostgreSQL. So messages severity levels categorize log messages by their importance, helping administrator prioritize and address issues effectively. Log verbosity setting is used to control how much information is captured in the logs, right? So whenever you want to diagnose any issue, you can use this log file. And this is about the log management, log file rotation. To prevent logs from consuming excessive disk space, PostgreSQL supports log rotation. There are two primary methods, which is time-based rotation and size-based rotation. In case of time-based rotation, PostgreSQL rotates log at regular interval using parameters like log rotation age. But in case of size-based, we can have the parameter like log rotation size. So as I said, like these are the files, and if you want to rotate the logs, we can do it. So in our test system, whenever we are restarting, we are getting these new logs. but in prod system, the seek system will not restart for many days. So in that case, if you have a log file that is consuming excessive space, if you want to control, there are two options. One is the time based and one is the size based. So in case of time based, we can set the time, like after these many days, the log file should create the system should create new log file. And in case of size based, we can inform by using this log rotation size, that how much size we need, and after that, the new file will be created, right? So this is an example of time based rotation. So these are the parameters: logging collector, logging destination. This is standard error. This is log directory. In case of us, we have here we have this log directory. Log file name, we can define the how it should for like the format we can define. And we can say, like in case of this time based, we can define that it should every 24 hours or whatever time we give, it should rotate. And in case of size based, these information we can put, like after 100 MB this should be done, right? So that we can do in our uh, our Postgre config file. So this is the parameter you can see in your PostgreSQL config file. So this is the information, like this is standard error and logging collector is on. You can define the this is by default I have set, so it is not enabled, but you can enable, and you can define your format, you can define your age, you can define your size. So this is all you can do with the log file, and this comes under the log file maintenance. So this is it for today, and I'll see you in the next video. Till then, please study and try to find more article and read more about this PostgreSQL. Thank you so much.